And we're back. Hello, everybody. It is 7 o'clock where I live. And this is the start of episode 34. It's hard to imagine. There's been so many already. Of the Unhindered by Coding live stream. Hello, esitsu. Wonderful to see you, especially since I know it's really late for you. I'm so sorry. Episode 34 of the Unhindered by Coding live stream. We'll be here for 2 hours from 7 to 9, working on evolutionary computation in Rust. So working on trying to build a reasonably flexible Rust implementation of a basic evolutionary computation system, genetic algorithms. And that's the battle plan. Thank you all for being here. We will start off by actually going here. So I was just trying to think about what it was we needed to be working on. So I started actually making some notes so I'd have some idea what was happening. So I think the big picture thing is, I think we have parent selection in a reasonable place, although there are a couple of changes that I want to at least propose and maybe even do tonight. But then the pipeline of mutation and recombination operators is still kind of a hacked up mess and needs to be made better. So that's kind of the big picture thing. Two less big picture-y things that we might want to think about are the first. Actually, let me go. I'm in the code. Let's go to. That's in U, right? No. Yes. So last week we made a parent selector type. So at the beginning of last week, I had thought we would be able to make an iterator that would produce essentially a lazy infinite stream of parents that we could then pass around and other people could then dip into and take from. That didn't work. And the main reason that didn't work is an iterator like that needs to be mutable, and only one piece of code in Rust can have a mutable thing. And I was going to pass this iterator all over the heckingon, and that wasn't going to work. So we ended up, instead of making an iterator, we just created a parent selector type. So this was basically a simple version of an iterator-like thing, but it saved us the mutability problem. Because the mutable part was the random number generator, that has to be mutable. And in the iterator, that was going to be inside the iterator, and that made the iterator mutable, and that got us into all kinds of trouble. If we could pass the random number generator in as an argument to what we're calling get now, what would have been next in iterator land, then the parent selector is not mutable. It stays put, and it's just the mutation is held outside of that and passed in as an argument whenever you need it. Well, iterators don't. The next function in an iterator doesn't support any way for us to pass something like that in. So all we could do was internalize it, and if we internalized it, we got into trouble. So we went to this approach and made this parent selector thing, which totally works. So we've got a type. The parent selector holds a reference to a population and a reference to a vector of selectors. And we can construct one in the obvious way. And then there's a get method that basically says, from the selectors, choose one at random. There's some things I want to talk about that. And then we call the selector on the population, and that gives us an individual, and life is all happy and good. And that all works. So this does the right thing. Thinking about it, though, after the fact, and that's this first to do, is should this just become part of the population type? Like right now, the parent selector contains a reference to a population, which works. But we could move the vector of selectors into the population itself and have the get method be just a method on the population. And we would pass the selectors in when we construct the population, and a function that takes a population, generates a new population, could pass the selectors on. So the selectors would just propagate through time. And it's a reference to a vector anyway, so we would just be making a copy of a reference. So it's not a big deal. And I don't know, I can't think of a reason to prefer keeping it as a separate type. I don't know that it particularly bothers me having it as a separate type. But, and in general, you know, I think making separate types or functions or modules or whatever is usually the good solution when in doubt. But on the other hand, if it's not really helping anything, do we need a new name and a new type for people to think about, or can/should this just be part of a population? And I'm not sure. So, and it is, no, there's nothing in, yeah, I don't know. It's not clear to me what would be the best thing to do there. So that's a thing that we could work on tonight. If we decide that moving this into population is a good idea, we could do that. The other thing, which I definitely want to do, and so maybe that's the thing to do first, is currently ParentSelector has a vector of selectors, and that vector is, we use choose down here. So we're essentially treating that vector as a uniform distribution. We're always going to pick each selector with equal probability. And that's not how these things are typically done. Usually there will often be a variety of weighted selectors. So you do mostly this and sometimes a little of that. For example, if you have elitism, where you just take the best individual and copy it forward, you typically only want to do that a few times. You don't want to do that a lot. Right now, if we put elitism in this vector of selectors, it will be as likely to be used as anything else. And if we go over to, do I not have live anymore? Yeah, I do. Don't need you. So here's do main, which is a terrible name and should be fixed. Here's my kind of cheap hack at a weighted set of selectors by basically repeating some of them. So this has best score. So choose the best, an individual with the best score. There could be ties, and we'll just pick one at random. I think it actually picks the last one in the population. Random, which literally just picks a random individual. And then 2 instances of binary tournament and 1 instance of decimal tournament. And binary tournament is, and decimal tournament are both instances of this make tournament selector thing with different tournament sizes. So binary tournament has a tournament size of 2. Decimal tournament has a tournament size of 10. And tournament selection, you're just going to take K, where K is either 2 or 10 in these examples, K individuals at random from the population, and then of that subset, select the best one. And you do that multiple times. The better individuals tend to be selected, but there are chances to choose kind of more middling individuals. So it's a little less aggressive, much less aggressive than something like best score. And so this would do binary tournament 40% of the time, decimal, random, and best score each 20% of the time. That's still like probably way more best score and random than you would typically want to. So it'd be nice to have, oops, no, not that one. Yes, that one. To modify this so that it was a weighted collection of selectors, and then there is a weighted choice option that lets us choose according to those weights. And so we could specify a weighted collection here and get weighted selection here. So that's a thing that I'd be interested in doing. And that we could definitely do. So let's see, comment from esitsu. Can you wrap the population in a new generation type that includes a population and a selector that you can call next on to get the next generation? Oh. Yeah, so I've been putting a lot of logic in population. I don't know, not tons. So there's new there's parent selector. I don't know, why is that even in here? Why do we construct a parent selector here? It doesn't make a great deal of sense. Other than it lets it, since the parent selector has a population, it lets it pass that in. And then we have the best score random. So we have these different selectors. And then, so yeah, what I was thinking of is in bitstring, population bitstring has all kinds of stuff in it. So it has next generation. Actually, now this is the one, the next generation with selectors. And so you're suggesting that instead of having that logic in population, we could put it in a generation type that holds a population and the selectors instead of putting that stuff in population. Actually, I like that idea. Can I think of any reason why that would be not a good thing? No, not really. Actually, I think that makes a lot of sense. Maybe that would be the thing to do first, and that would essentially resolve this first to do, because this would just move into the generation. This logic would move into generation, and we wouldn't need this separate type here. And then we could worry about adding weights to it after we got that done. Now, I think it's an interesting idea. I like that. And I think it makes more sense as a type than perhaps this guy does. Okay, so we're going to want a generation. So let's go back to lib. Let's think about what this would look like from here. Actually, let me also make sure I got a branch. Oh, did some random things. I created that, and this I think was just comments. Yeah, so let's document some to-dos for the project. I also created a planning document to help me keep things straight in my head. Boom. So I'm going to branch, create generation type. Composable selectors with traits instead of an array slice. I'm not sure I understand what you mean. Do you mean selectors here, or do you mean things that do mutation and recom and like crossover, that kind of stuff? So, because I think of there being the selection is I'm reaching the population, I'm choosing parents, and that we don't tend to compose. We just have like a set of selectors and we want to like choose one. Whereas the mutation, crossover, recombination stuff, that we tend to compose. And so maybe that's what you mean instead. Is it always a random choice as to which selector to use? Typically, I mean, always in evolutionary computation is a dangerous term because there are a million flavors and everybody's done things differently. But yeah, usually there's some set of selectors, and for each parent choice, you're picking one of those selectors at random to be the parent, or to be copied into the next generation, which is sometimes done. And then parent selection is entirely random from that population, but biased by the selections that were made earlier. But I'm not going to try to implement every possible version of the world. So I'm just going with we are going to select parents, and we will have a set of selectors, and we will pick one of them at random, preferably with some kind of weighting, is the way I was thinking of it. So I don't know if that helped or made sense, but definitely ask if I'm not making sense, because no point in having me just mumble here if nobody understands what I'm talking about. So, I guess, so right now, we have population, new bit string population, which is implemented in, actually I'm going to close some of this stuff so I can get at things a little bit more easily. Population, new bit string population is defined here, which calls the underlying new in population. I guess a question is whether we would construct the population here, or we would construct the initial generation here. And I kind of think we would construct the initial generation here. That if we have our selectors, then we would do something like let generation equals generation new say initial bit string population, and that's going to take pop size and the bit length and the scorer and the selectors. So it would do something like that. And so this would disappear. We'll have to tidy some stuff up, I guess. Oh, but that's interesting, because talking about the best individual from a generation actually makes a lot of sense. And it could just call through to best individual in the underlying population. So actually, most of this could probably get copied down here. So we would assert that generation dot individuals. Oh, let's see. So population is a wrapper around just individuals. So would we want, like if we did this just sort of in a brute way, we'd have like generation, population, individuals is not empty. But we could actually just say generation isn't empty. Or maybe it's better to say that generation.population is empty. And then I really should put an is empty in population so we don't expose the individuals the way we currently are. And then we would say generation best individual, and actually there's not an unwrap anywhere. That's weird. What did oh, so this did the unwrapping. So this allow Clippy was just not there. It didn't need to be there anymore. Generation best individual, and this would be generation.population dot size. Force us to make a size method, and let's see, the bit length would say the same. And now this use of generation is a problem, so we really want to change that name. Who knows what that's gonna try to rewrite. So we probably want some generation number here, and that goes here. I think that's gonna be it. Oh, yeah, just those two places. Okay, so that would be what that would look like, I think. And then this would all go away. Boom. And except for it's not going to be population anymore. It's going to be generation equals generation dot next and we wouldn't actually pass it anything. we just say go. And that does mean this is going to need to be mutable because we're going to keep overwriting it. And I bet there's a better way to do this. There's probably some iterator thing that does exactly, like applies a function repeatedly to, or a closure repeatedly, and gives you back the sequence of, I it's like for each. Oh, I'm using for each. That's exactly what I'm doing. Oh, okay. Well, maybe that's our best bet. Yeah, that's probably reasonable. And this would be generation, the best in the generation. And this would be, I don't really need to keep reprinting the population size or the bit length because those don't change. I think that was just a debugging thing. Whereas knowing the best individual in the generation is probably useful. Okay. So that actually doesn't seem like a terrible thing. And now there's a whole lot of things that are not going to work. So, whoa. Hello, that. So I think it's just grumpy because it's never heard of generation. So we need to have a generation, mod generation, and it's like, I can't find that. Well, let me just make it create module. That's nice. Did that do the right thing? It did. So comment, here, let me hop back here. I construct a generation and pass a population instead of a specific bit string population method. So if we construct, so I'm guessing one of the things you're trying to do is avoid having the generation tied to the particular kind of population that we have, and that would just stay, since the generation only does selection. Well, it'll also have to do recombination, but that doesn't have to necessarily expose the bit stringness of things if we're careful. If we can keep generation from not having to care about the bit stringness of things, then that would be potentially useful. Yeah, I see that. So then we did actually probably want all that population initialization stuff. Yes. So actually I'm going to cheat here and steal this. Can I do that? Come on. Let me. Oh, certainly you'll let me do this. Or not. Well, that's annoying. Get diff. Well, we can do it this way. We'll have all this waffle, but we'll get there. So that makes the selectors. I've got the score. Put that together so the selectors are in one block. Oh, wow. This is going to be a mess. Whoa. Now, so all of that's still messed up, but this is now okay. We don't need this anymore. I guess we'll probably assert that population is not empty and skip this part. Maybe? I don't know. We'll leave it there. And then I'm going to actually take these guys out and assume that they'll be handled down below at the generation level. And yes, we'll have to define that. And then this will be just new. And oh, that was compute score. That was never going to work. Now, does compute score belong in the population or the generation? I feel like it's a function of the individuals in the population, so I think it makes sense to pass it here, which means we don't need to pass it here, and the generation just needs the selectors. Oh, but it needs the population. Population and selectors. Okay. That seems plausible. Does that seem like the kind of thing you were thinking about? I'm going to actually add this because that'll be easy. What? Come on. No quick fixes. Really? Oh, because it's... Oh, sorry. I wanted this one. Population. Do we really not have like a... fine. So I need to go to population. And I want to impl. I'll just put this in here. Pub fun is empty. Turn. Oh, take a reference to self. And return Boolean. And that's going to be individual self.individuals. Oh, which it was trying to help me do, and I did the wrong thing. Dot is empty. Oop, no semicolon. Oh, yeah. So that takes care of that problem. Then we're back to lib. And lib's grumpy because nobody declares the type generation, so we need that. Pub struct generation, which is going to have a population of type population, and that's going to need a type T, which means generation is going to need a type T. And okay, that did a thing. Now we don't have a... Oh, we need to import. Do we need to import? Yes, presumably. So, did this give me the ability to... Aha! I even figured that out. Good job. So that takes care of that. Now we need a new, which we don't have, which takes a population selectors, impl for T, generation T, pub fun new, takes population of type population of T, and what was the other thing? It was the score? Yeah, the score And scores have type. Oh, don't I have a like? I thought I had a type for those somewhere. Is that going to be maybe in here or not? There we are. So it's one of the. Oh, are we going to have to do this R thing? I bet we are. Yeah. Okay. So this R thing, this really threw me. Oh. No, selectors. Oh, you're right. No, you're completely right. It is selectors. Oh, whew. I was about to get into a crazy mess that I didn't need to get into. So we're going to get past a vector of selectors of type T. Actually, we're going to get past one of these things, but with T instead of bit string. Selectors. Thank you for catching that, because I would have really gone down the deep end. And we would have been super sad. And that's going to return a self. And it's not a reference to self because we're actually going to make one. So that's going to have to be imported. Boom. And that. Oh, we just haven't done anything yet. Okay. And so a generation is literally just going to be self, population, and selectors. How did I not get selectors here? Oh, because I guess I didn't realize I needed one. But I'm going to need selectors, which is going to be this is actually going to be a reference. Because I don't want to own the selectors, because I want to be able to pass them into future generations by reference so that I don't get into an ownership problem. And I only have to read them, only have to use them, I don't have to change them. However, we now have a lifetimes problem. So I need the population, the selectors to last as long as the generation lasts. And that needs to have, and each individual selector needs to last that long as well. So that makes sense. And I'm owning the population because each generation, it makes sense for a generation to own its population. So I don't need a reference there. It's okay to just have the population. But I do want a reference to the vector of selectors because I want that to pass along through the future ages. And so we're going to have that. And that's it. It was able to figure everything else out. Did I actually? Yeah, I would have needed that. Cool. So that did a thing. And this probably needs to be a reference. Yep. That takes care of that problem. Population is not public. Is there a reason to try to hide that or not? I don't immediately see why I want to hide the fact that there's a population there and what its type is. So I don't think I'm going to bother encapsulating, doing a bunch of stuff to encapsulate that. And then we'll need a best individual. Oh, yeah. I'm just going to need to add best individual, hub, fun, best individual, self, return, reference to individual of type T, and we will just call population, self.population dot best. Really? Is there not a best individual in population? Surely there is. That's the ParentSelector stuff. There's a best score. There's not actually a best population. So there is one, I think, over here in bitstring. I think maybe I've got it kind of in the wrong place. Maybe. Or maybe not. I could have sworn best individual. Oh, there it is. Yeah. Oh, it's just a random function. No, because it talks about self. Okay, it is somehow a population bitstring, which is goofy because it really doesn't belong there. Like, this really belongs in individual, not individual bitstring, or population, sorry, not population bitstring. So if I cut that and I move that to population in general, there's the basic population is empty. Let's put it there. Best individual type T, and all the rest of that works. So we're asserting that we don't have an empty population, and that allows us to do the unwrap down here. And so we take the population, we extract the individuals, we iterate, turn that into an iterator, max by key, where the key is the score, and we unwrap. Okay, so I think that's all still good. And that, then we ought to be able to say self.population.best individual. Or not. Oh. T.send. So that's because we're using threads. So the population needs T.send. So that means generation is going to need T.send. And that goes on. Oops, no, wrong place. That goes on the impl. That implies all of these things are send. And really, we don't need send for either of these two things. So we could probably imply less. By doing that, and then generation doesn't have that problem. Okay. Yeah. Now you said move it out into its own. I guess one thing I don't know is sort of best practices in Rust land. You could have every method on a type be in its own impl block, or you can organize them into different sub impl blocks. And I don't know if there's like a, do people tend to do it like, it makes sense, I guess, that these would be split because the assumptions are different. We want the ones, we wouldn't want these guys to be making that send assumption if they don't need it. But is it reasonable to have isEmpty and best individual here together as sort of, yeah. So if they share a set of constraints, then go ahead and have them in the same impl block. Or if there's some other dependency that they share, then have them in an impl block. But putting them all in separate impl blocks seems to be like too much work. So, okay. So that makes sense. I like that. So now we have a best individual that just passes along to population. And I kind of assume / hope that the Rust compiler will basically inline something like this so that calls to generation best individual don't actually incur another function call, that they just go straight, get rewritten as calls on the population.best individual, since there's no guard or anything associated with that. Fingers crossed that would be true. I don't know. So where are we here? Right. I changed. I thought in the evolution computation world, people talk about the size of a population, not the length of a population. So it seems like it would make sense to have a size self.individuals.len. And what does that actually return? Usize, okay. So that's reasonable. And so we're close to done here, right? Yeah, so we just need to implement next. There's an inline attribute that I could use. That would be exciting. Oh, come on. Oh, fine. Does that work? Come here. Oh, stop it. Nope, that did not work. Oh, come. What in the world? Okay. I am having trouble copying and pasting the link. So if we just add an inline, it suggests performing an inline expansion. We could say it always needs to, and then it never should. Oh, that's interesting. Cold, which was not what you pointed me here for, but you can suggest that a function is unlikely to be called. That's interesting. I don't know immediately what I would do with something like that, but it seems like I could imagine a circumstance where that might be a useful thing to tell the compiler. Well, I think, and it says in the note that incorrectly inlining functions can make programs slower, so this attribute should be used with care. I am of the opinion that in general the compiler is smarter than me, and I'm not probably going to benefit from trying to tell it its business. So I'm going to just leave that alone, but it's good to know that that's there. And I guess if I really cared, I could look at the compiled code and see if it in fact was inlining that, or if I did some profiling and I found that somehow I was spending a great deal of time here, I could worry about it. But in fact, this is only getting called a few times per generation. And so I don't really think it's likely to be of any particular consequence. So I'm going to leave it be. I still hope it gets inlined. It will. I should take that back. if the compiler thinks it's a good idea, I'd be thrilled if it was inlined. So, okay, next. So now, basically, we want to steal this next generation with selectors is going to get moved into generation. Now, did I have a next generation here? I don't think I did. No, I think I never got around to making a generalized next. I only had the one over here in bit string. Now, ultimately, we want to make a generalized one, but until we resolve the parent making part of the program, the mutation recombination stuff, we can't fully do this in a way that is independent of the underlying type. So, for the moment, actually over here, oh yeah, so if it knows that this is a vector of Booleans because this population is a vector of Booleans, right? So it knows it's tied to a generation of bit strings. So I'm just gonna like hack this in here for now. Generation bit string, and we'll need to sort of fix that, but for now it'll be okay. And that takes, so we're going to need a next function that returns a new pub fun next that takes a reference to self and returns a new self. And if I say this, lib now compiles. Zippity doo. Can you abstract the inner map closure so that you can store it in the generation? So you're looking at this closure here, I'm assuming. Oh. So if you pass this closure in, that's the only thing here that is depending on. Oh. Yeah, maybe. That's an interesting idea. Huh. Yeah. And then I don't think anything else would care. And we could generalize this. So we could make this T and then actually get rid of this dependency so that we're reminded if it comes back up again, and it shouldn't. So the body of next is going to look something like this. But we're going to need to extract this part out. Right, that goes to here, yeah. And if I say this gets make child, useful if I can spell, collect, and now a generation's going to have to then have a make child thing. Let's go through and try to fix the other pieces before we get there. Oh, and this is still going to be of type. Oh, doesn't even seem to know. Why not happy? Oh, we have to actually provide a thing. Yeah. Okay. So this would be so we'd have to make a new population, which is just a wrapper around individuals anyway. And we'll have to pass the selectors along. Selectors. And why are we grumpy? Oh, because I gotta say population. Population is a population of individuals. Selectors. Oh, it's self.selectors. And why are we grumpy? Oh, because again I have to give it the name because it's not actually the thing. And this is grumpy because of this. Make that go away. And now this is unhappy. Fine. This is unhappy. Oh, because I think we have to import rayon into parallel iterator. Okay. Oh, and map init takes. Oh, I lost the. Weird. Somehow I lost that part. Yeah. And actually, I really don't need those to be on a separate line. We can just bring all this up together. Up together. Be my friend. Okay. Map init. Is an import. Yeah. And then we got to put that guy in there. So map child is going to have to be, or make child, presumably is going to be in the constructor and stored here. Make child is going to be, I don't know, it's going to have some weird function type. So bool's clearly wrong. I just want to figure out what this needs to be. Oh, that would be self. And then presumably this is going to tell me. Really? That didn't like fuss? Oh, we'll have to pass in make child. I feel like there's a way I can say Make a copy. Isn't there a dot dot or something where I can sort of say, here's the new part, everything else is the same as some other struct, I think. Now, okay, why is T? Oh, because I have impl a T. That will help. No field individuals because that's in population. Oh yeah, right. So we have to population dot individuals, and that's going to be parent selector. This is inside individual. Let's see. So the closure captures the parent selector, so you may need to wrap the call to make child in a closure to pass it. Right. Yeah, make child needs to have the selectors, and it's not going to have that since there's not a closure. It won't capture it. Yeah, good point. Thank you. Now I feel like there's a piece ahead of that, which is so parent selector in population land, because this is impling for population of bit string, right? Yeah. So parent selector must have been in population. Really? I'm going to think about that in a second. Self.parentSelector. What is this? Go to definition. Oh, so I do have this parent selector thing in population that constructs a new parent selector with that population and the set of selectors. Which I don't really need. And if I'm going to move the logic for parent selection into generation anyway, I don't think I need this. I think I just need the self selectors. So if I take that out, now we get to your question. If I pass in, okay, so let's start with this. It wanted a fun that took a threaded RNG and a U size. Why a U size? Oh, the threaded RNG is the this thing here, and the U size is the which number we're taking. So yeah. So make child's going to need to be an FN, actually presumably a reference to an FN that takes a thread RNG and a usize and returns so when you say mapping the selector, are you, I think I'm not sure I'm following. It's been a long day. But it's later for you, so I can't complain. Are you suggesting that this needs to be a closure, or that... Yeah, I'm not sure I'm following what mapping to selector means in this context. I'm not sure what we're mapping. I get that we're mapping something to a selector. You said earlier, if you do into par iter dot map. Oh, I could. Yeah. Although that seems kind of opaque, right? I could be like, take nothing and return the selectors and or self.selectors, I guess. Self.selectors. Why are you grumpy? Oh, did I need a curly brace around that? No. I'm doing something else silly. Oh, no arrow. Yeah, duh. So I didn't need the braces. So now this is going to have so this function will take a threaded RNG and a set of selectors. Okay. So this now, instead of a usize, is going to be a reference to a vec of reference to selector of type T. And that function is going to return an individual of type T, I think. But it's grumpy because I did... Oh yeah, I'm missing a angle bracket. Whoa, not happy. Oh, is this an impl or a dine? I think this is a dine, right? Does a dine go here? No. Oops. Nope. Not happy. Oh, because lifetime. So that function certainly should last as long as the generation. So that seems to be not an insane thing. Okay. Now we're going to need this whole nightmarish type. Okay, so we really should give a name to this. If I can. I got into issues when I tried child although it make child is also going to need the population, and it doesn't have it anymore. It has it over here because the population has been, oh, actually, no, it didn't need the population explicitly because we made a parent selector which wrapped the population. If we don't do that, then we will have to pass the population in over here. We could pass a reference to the whole generation. So then this would just become reference to self. And we'd have the whole generation available to us. So then this becomes a reference to a generation. I probably need to say T here, or it'll be fussy at me. And why is it unhappy? Oh, I was in the middle of making a type, which now I perhaps don't need. No, it does not like that. Probably because I need a dine. Yeah. So then I think I could make this child maker. And then this is going to be a child maker T. I think it probably is a reference, right? Yeah. And then that goes there. That's all happy. And now this is grumpy. T cannot be shared between threads safely. Oh, so it needs, this does need send, and maybe also sync. Yeah. And that did not make it all go better. Oh, that function isn't. Oh my goodness grief. Okay, I'm actually going to come out to the terminal and say cargo build. I want to see this out here. Within reference to generation T, the trait sync is not implemented for this function. Aha. I think this is where I need the R thing. Oh, so much sad. I was hoping to not have to bring this up. But I think this is the problem that I solved elsewhere by introducing another type. So let's see, where's a place where that lives? Yeah, okay, right here. So here, to pass in compute score, that took so I wanted this to take a function that took a, you think I may just need to do something simple. Let's hope you're right, because man, I'm really trying to avoid explaining this thing. So you think that here in this type, or here when we pass it in? Let's try. Oh, you might be right. Did that make things better? Fun. Reference meet Fred. Reference generation. Found function. Oh, I didn't say and mute somewhere on the thread. I think. Yeah, so the map op takes an and mute thread. And I just have it taking a thread. So this needs to be an and mute thread, RNG. And that would make that better. Now, I've got too many. I think the problem here is I got too many ampersands. I've got and mute thread and ampersand gen. Here I have and mute thread and a single ampersand. So somewhere I am passing too many ampersands. No, it expected 2, but it only got, and it got none. So I get that it would need expected ampersand generation, but found 1 ampersand. So, okay, I'm going to actually sneak out here again. Oh, yeah, we can deal with that. So, expected two ampersands, but found 1. So you're suggesting try removing this ampersand here. Oh. Okay. Well. Swell. Somehow. Oh, but that's a reference to self. This is my mistake. It's I thought I needed to make sure it was a reference to a generation so we didn't take ownership, but it was already a reference to self. So this was already a reference, and I missed that fact. Holy moly, all that compiles. And we can fix this easily. So it's supposed to be child maker. And then I think we can get rid of this comment. And so now we just need to pass in the right closure here. Okay. So that would, let us make essentially this closure would go here. And this is going to be not underscore, but it's going to be generation. And let's so that should be, so why is all of this super grumpy? Expected. And then it takes found unknown, because it doesn't have any idea what. Oh, well, RNG isn't even defined. So this is going to be thread. What? Thread RNG. Oh no, this is a closure. It's not supposed to be an actual value. And it needs to be a mute ref. And a generation needs to be a ref. Or not. Where are we in? We're in domain, yeah. So we're going to need to pass a reference to the generation. But we will need needs to be a reference to the oh. So you're saying we need that? Oh, wow. That made a whole lot of things a whole lot better. Let me think about that for a second. So this is a reference to a function. Yeah. And so this had to be a reference to this closure. Okay. That actually makes sense. Now, ParentSelector doesn't exist, but we have a vector of selectors, so we can move, we could create a select parent method in generation that would, actually we could just have a get method in generation that would get a parent, and that would do these two things. And then this is going to need compute score, which we have. Oh, it's called scorer up here. So this is going to become scorer. And this just needs to be imported. Boo-ba-doo-ba-doo, ba-ba-da-ba-ba-ba. Okay. So then these two things, we should just have a get method in generation. So I think what we want is generation dot get parent RNG like that. And if we do that, why are you fussy? Oh, really? That's interesting. Why did that not happen before? That did not work. I'm going to back out of that. Come down to that in a second. Let's do this problem. So we need a get parent that takes a threaded RNG and returns an individual. And that needs to be in generation. And that is T going to need to be send sync for that? I don't think so. I think we can put that in here. Fingers crossed. Pub FN get parent. Is that what I called it? I think. Get parent. Yep. Get parent takes a RNG that's a thread RNG and returns an individual of type T. Turns a reference to an individual of type T. And that means we'll need that guy. And to do bang. So things compile. And over here, things don't compile. For the send sync situation, you could rename next to par next and create a separate next method that doesn't use rayon. Oh yeah, that's an interesting possibility. If I wanted, and you might want, all of the implementations are going to be identical. Oh no, they aren't, because this is actually where the into par stuff is happening. Yeah. So it would kind of make sense maybe to call this par next. I wonder if I can rename and have that work, given that some things aren't compiling. Oh yeah, so it did par next there. That's good. So I like that. And then we could add a to-do, create a next that doesn't use parallelism. I.e. skips the into par iter bit. Yeah. Okay, so why were we grumpy here? Get parent. No name. Oh, it's got to be, no. Generation. I've got pub fun get parent generation.getParent RNG. What is your grumpiness? This is in generation. Oh, duh, thank you. And it was even trying to tell me that. I didn't get that that's what it, okay, yes. It was trying to, if I back out and I come back to the error, it was saying found the following associated functions to be used as methods. Function must have a self parameter. That was the problem. I wonder, is there a get fix that would actually do something there? No, that totally would not have helped. So, and self. And that makes that problem go away. And we need to say and mute Oh, actually, the problem's over here. And mute needs to be here. Okay. So that all compiles. We'll have these problems to deal with, but we'll get there. What time is it? Oh, it's 8:30 already. Time flies when you're programming. So get parent is going to... Oh, so we don't need... Because this is and mute here, I don't need this and mute. And the problem was actually down below in the called code. Yes. Yes. Okay. But I do need it here because I need here. There's no way to know that it's going to be called with a mutable reference if I don't say that. Gotcha. So we need to select a selector and then use it to get a individual. And that's the whole parent selector business, which basically we have this code here. Boom. Whoa. I got a little too excited there. Oops. So we're going to get the selectors. We're going to choose. We don't have that. And then we're going to call the selector with oh, we need to get rid of that. And this is going to be wrong because S returns an option, and so this code returned an option, and we unwrapped it over here. So if we assert bang that self.population.is empty and put a not in front of that, then this should be safe to unwrap. So if it is, then we should be able to safely unwrap the selection call. Okay. And this is not expected a reference to population but found an actual population. Oh, interesting. So we need a reference there. That, yeah, because the generation owns its population, so we want to pass a reference to the population into the selector. Oh, and that doesn't take that actually needs to unwrap as well. Oh, so we've got to assert. So that really is about this one. And there's another assert to be done. Self.selectors.is empty. And the set of selectors should be non-empty. And if it is, then we should able to safely unwrap the choose call. In fact, rather than checking this over and over again, this really ought to be checked once when we make in fact, actually, both of these ought to be checked once. Empty. So if we check those when we make them, and they're not mutable, they never get changed, so we can avoid doing the assertions here and here and where was I when I was getting, oh, right here. So we can skip that and that. Yeah. So these assertions should make this safe. So now, does everything compile? No. We've got 2-point crossover doesn't work. So no method for vec bool on the current scope. Somebody has that. Yeah. 2-point crossover. So I made a trait linear crossover, and vector of t implements 2-point crossover, and we're looking at vector of Boolean. So we've got a vector of Boolean. Why does that? Items from traits can only be used if the trait is implemented and in scope. Oh, is the trait not public? Oh, look at that. So this do these need to be public? Whoa. Why did that yell? Oh, because it's implied. Why are you still grumpy? Oh, do I need to use the crate? Yeah. So I need to use linear crossover as a trait. Import it. Wow, this has gotten insanely complicated up here. That is a really long line. But now this is another trait that needs to be brought in. So linear mutation probably isn't, yeah, that's not public either. And so that's going to need to be imported. Linear mutation. And now, whoa, blew up the world. And it's grumpy about lifetimes somewhere. Temporary value is dropped while borrowed. Okay, I can't see the little pictures. I like the little pictures. Oops, no. Cargo, build. Explicit lifetime required in the type of selectors. Oh. So I need to, in the new method in generation. Oh yeah, we blew up the world over here. So this needs to be that. And maybe that one? No, maybe not. Lifetime. Oh yeah, it probably is this actually. No, maybe not. Undo that until I know what I'm doing. Add a B lifetime. So it borrows from the population. No, and that's going to need a B there. Okay. So it gets an individual out of the population and returns it. I don't know that I understand why the population is owned. Oh, right. Because the population is owned by the generation. A only applies to the selectors and the child maker thingy. And so this would say the individual would last as long as the selectors, and we need it to actually last as long as the population. And so we can make that happen by being explicit about the lifetime of self, and that the individual being returned will live as long as the generation that we're acting on. And it's got to be does it have to be a different lifetime? I guess it does. I mean, if I take this out and I say this is A and this is A, it doesn't work, right? Or it does work? So is it really that individual that needs to just have a lifetime specification? Oh, this should be an ampersand. Nope. That does need to be there. And oh, but that one doesn't. Ah. Now you think maybe this doesn't need to be here? What did we I feel like we just back where we started from. Oh, because we're still a mess here. So what is going on? The two, so this closure creates a temporary, this needs to be creates a temporary which is freed while still in use. So when we construct the individual here, that gets make child is returns an individual. So we would pass ownership of this individual back, wouldn't we? And that would be okay. Okay. So that would, you're suggesting that here, I'll actually be really brutal and do that for now. Well, no, actually, we could call this make child. And then this is all of this stuff goes here. And then all of this stuff goes here. Okay. And then we would use ampersand make child here. Okay. That almost gets us there. Doesn't know what type this is. Oh. That's interesting. Yeah, because it's a closure and it doesn't have any... Well, I would have thought it could have figured that out from down here. But... bit string... And that'll be a reference, right? Reference to that, actually. And that's a mute thread, RNG, and then this is grumpy because we've got mute thread and we got a lifetime problem. Yeah, so it's not happy about the lifetimes here. So it can't tell how long things are supposed to last. And we want, oops. Actually, hang on. What? That's a reference to a mute. Oh, get parent. Is get parent not set up correctly? No, it takes a reference to a mute. What? Okay. Well, that doesn't need to be mutable anymore. I agree with that. Make that go away. The lifetimes on the make child type are child maker doesn't have any explicit lifetimes. Maybe that's the problem. I don't. You go away. So scorer does not live long enough. Borrowed value. Oh, am I just missing a move? Is that the syntax? Well, that made the scorer problem go away. That's a win. Borrow of moved value RNG. So it feels like this is moving it, but I don't want it to move it. I want it to just borrow it. Generation.getParent. Generation is of type. Oh, generation's here. And we need to capture generation in this make child. Oh, no, but that's not going to work. Oh, no, the generation is the argument. Oh, it's right here. Duh. Ignore all that. So generation is a reference to a generation. And yeah, let's try the cargo build idea. I like that because it does seem to be very confused. Although I think cargo build says the same thing. Whoops. Oh. Basically. So we've got this move. RNG has type reference, mutable reference to thread. And we shouldn't be moving it. We should be passing it as a mutable reference, which means that we give it back when we're done. So I'm a little befuddled. Now this is interesting. Maybe this is relevant. One type is more general than the other. Expected. Oh yeah, so this is the lifetime problem. Oh, so we try that. That was here, right? No. Oh yeah, because we need. So we put that back. Does this get happier? No, I don't think so. I think we're in the same place. Yeah. So we still have the value being borrowed and the more general type. So we expected thread RNG generation, and we got thread RNG without this lifetime. R with generation with R instead of S. And vec bool with no, oh no, with this. It's like somehow it feels like there needs to be a third lifetime attached to the individuals. We have the same problem here. Yeah, we have exactly the same problem here. So, oh, you're ahead of me then. I will await your brilliant proclamation. You can remove the B lifetime. Didn't need that. Okay, that's not too surprising. Okay, oops. So that's gone. Now what do we do instead? Go to the top of the generation file. Okay. And do we need a lifetime that associates the individual with the generation here? Like, oh, that would be, oh no, but that's not a reference. So I don't think that's the right thing. We want childmaker to make a new individual, not a reference to an individual. And we want this individual to last longer than that generation, which maybe is the problem. How do we say? Do we need like 2 lifetimes here? Can we add explicit lifetimes here? No. Oh, it would be like a plus thing, wouldn't it? I think. What compiles? Oh, use the for thing. Ah. So actually this something like that, and then we need to figure out where things go. So we have like A here, B here, and C there? No, that doesn't make sense, right? You can't put that on a type there. So what does C do? Oh, C colon T. Duh. Yeah. And generation takes a life. Yeah, right. Generation takes a lifetime here, so I would just pass one in. Oh, and the 4 goes after the dine. I'll take your word for it. I wouldn't have a clue. So does this just do this now? If you have the 4, you don't have any of the lifetimes in the left-hand side. I think that's true. Okay, that compiles. Now, where are we here? We still have, oh, no, we still have more or less the same errors. So we have the borrowed RNG business, and we still have the one type is more general than the other. And so here we have three. So here's our three things, but we only got two. So somehow we need to explicitly attach a lifetime to thread RNG in make child. So we need to explicitly have a lifetime for RNG so that we can say that it's different than the lifetime of generation. Because it's not attaching any lifetime to the random number generator, but it is attaching them to the other two pieces. So do I need an explicit type? Oh, yeah, we could do that. Okay. Now this one down here is grumpy, and it's the same problem. So ABC versus RNS. So this closure doesn't, so when they talk about this closure, they must be referring to make child. This closure does not fulfill the lifetime requirements because we have mismatched types. Sorry. It's inferring something here, even though this doesn't even have a body anymore. It's having trouble. Oh, is the problem that related to the fact that I had to explicitly say what generation was? Oh, is maybe the move? Is move bad here? Has move caused me trouble? No. Move didn't change anything. The same issue. Ah, yeah. Okay. Found FN mute thread and generation with unknown lifetime. So maybe I do have to actually be explicit about the types. Oh, so much noise. Yikes. That's like 1,000 copies of, I think, the same thing. Closure, thread RNG, generation 2 returns individual, must implement A, B, 1 for any lifetime 1, but actually implements mute generation 2 vecbool for some lifetime 2. So do I have to actually be explicit about the types here with, I don't know, is this another for thing? Oh, esitsu's got a thought. Go back to the generation file. Okay. Move the C lifetime to before the T. Oh, here. And then get rid of it here. That breaks this. And C would be saying how long the things, the individuals inside the generation live, which really ought to be the same as B. I would expect, oh, no. Yeah. No. Maybe not. I was thinking that individuals would last as long as their generation, but if make child is happening in a thread somewhere, the generation could go out of scope before. But no, we need that to live as long as because I don't know what I would put here. Well, it says use A. We'll use A. Does magic happen? No. Now we just break other things. Yeah. So I would expect the individuals inside a generation to last as long as the generation. I mean, I would expect this to be true. And that therefore that wouldn't be necessary. But then we have the same problem over here. So this is saying we don't know how long the things inside are going to live. Now can I put like a oh come on. I guess I'd have to be explicit, wouldn't I? A mute thread RNG, and here I want B generation bit string. Does that make things better? No, because that syntax probably doesn't work. I'm really sorry. It's really late for you. Maybe we should stop. It's 15 minutes after we were officially supposed to be done. And I know I'm not feeling very smart at the moment. Cannot introduce explicit parameters for a closure. Remove the parameters. Well, that is not helpful. If I remove the parameters, then I'm sure that these things will all be broken. Consider introducing lifetime A here. On line 10. Well, I mean, we could. I am not optimistic that this is at all useful. Now we've got grumpiness that A must outlive static. Now I could imagine, I mean, is this maybe going to help? If the thread RNG, if we said that is static, does that somehow magically make something less bad? Ooh. Well, if we then go over here and we say this is static, that doesn't break anything on this side. Oh, yes it does. What do we break here? Collect. Really? Oh, Because that thread RNG doesn't actually have static lifetime. So saying they're static isn't going to help. Poop! Okay. I'm going to undo the static. And I'm going to decide that we should quit. Oh, you've got an idea. Undo all the lifetime stuff being like this lifetime stuff here? Now that compiles? Because these are never used, so it doesn't really matter. Undo this lifetime stuff as well? Up here? Yes. Oh my God. What did we do? So simply having explicit types here. Oh, this is all still uncommented. If we bring this back, presumably something bad will happen. Not very much. Score does not live long enough. This is the only compile error. Is it scorer? Oh, and I put the move in here so that that would get captured in this closure, and I think that then broke the world. Now that I think about it, if I put the move back, did everything go to... Oh, no, it all compiles. Whoa. I'm so confused. I'm going to come back to the terminal because I don't trust myself. Look at that, it builds. What? No! Yes, good, but no! So somehow putting these types in and the move all together had to be there, and maybe I never had them all in the same place at once. So if I say cargo run, I get a run. Actually, I'm going to do a cargo clean because, you know, I'm not sure I really trust any of this at this point. So I feel like we needed move, we needed explicit types, and we probably needed the for thing so that we distinguish between the lifetime of the thread, RNG, and the generation. I'm guessing, he says, not really having any great sense of what's going on. And it runs. I may be killing the quality of the stream. Sorry. I'll stop doing that. Since it's paralyzed, it eats all the cores, and I suspect the streaming system is like, whoa! So you think I can remove the B from get parent now. So you think I don't need this. Oh, there's no reference to it anywhere. So it definitely shouldn't have needed to be there. Except, yeah. Do we build? We are contemplating our naval and probably eating the quality of the stream. Okay, yeah, it builds for real. Okay. Wow. And so, yeah, this is using the new code. So that does, I think, work. Darg! So, um, yeah, I mean, if it's fundamentally true that this lifetime's got to be, well, but there's no reference to the lifetime over here. So it's not obvious why we care that those two lifetimes are different. Actually, yeah, I don't know that I get why those have to be different. I mean, if I were to comment that out, take the 4 business away, and that blows things up. Oh, that's just because. Oh, it's because I still refer to B here. That compiles. That actually builds. Yeah. Weird. So it didn't need that. So yeah, so the real issue was being explicit about these types here. Trying to let it infer those types was just a bridge too far. And in its attempt to infer them, it got very confused and did dumb things. Well. That was exciting. By some definition of exciting. And we need this lifetime because we have references to things. And if you have references, you need lifetimes on them. Do we need these lifetimes? Or is that just going to be obvious that they're the same? No, does not like that. So it needs, when it builds this, it needs a lifetime for selectors and make child. And I guess it needs to know for sure that they're the same, because they could possibly be 2 different lifetimes. Maybe. Okay. Well, I'm ecstatic, if a little tired. So I'm going to commit and quit. I'll close the stream down so you folks can go home and go to bed while I do that. Thank you so much. Esitsu gets another huge gold star. We got to figure out like how to. I can reward people with stuff in Twitch. I don't know how any of that works, but Esitsu has earned many prizes for all the help that you've provided, and thank you to everyone else who was here and who was listening, watching along. It is greatly appreciated. So it's Wednesday night. We will stream again Saturday morning at 10 o'clock Central Time. We'll do ice-repos, where we are close-ish to having the review and submit part done. We'll probably have to deal with OAuth or some, OAuth, with authentication with GitHub. I think that's probably going to have to start Saturday. So that'll be exciting. And I think in the absence of any great suggestions from someone else, I think the Cloudflare idea and using Cloudflare workers seems to be a pretty reasonable option. So I think we might get into Rust in Cloudflare. That'll be different. And then Saturday afternoon, we will return to systems labs, and I will need to pick a new lab. I haven't done that yet. I'm sort of waiting to hear back from a colleague who might have preferences on where we go with this. And if I do, then that might guide my decision. And if I don't, I'll just make something up, because that's what I do. So you're awesome human beings. Thank you all very much. It's greatly appreciated. If it's late where you are, I hope you get a good night's sleep. And I will talk to you folks later. Goodbye.